Hello, my dear students. This is Dr. Vivek Rohira, Mathematics Mentor. And today, in the chapter number 1, we are going to start in the real numbers, the revisiting irrational numbers. So, in the chapter number 1, real numbers, today we are going to start revisiting irrational numbers. So, let's see. As you can see the example, before revisiting the irrational number, we just understand the concept of co-prime numbers, 16 over 36. Okay, so by simplify, we can see that it will be 4 by 9. So now, 4 by 9, they both are co-prime numbers. So before starting the irrational number concept, we should know that the 4 by 9, they both are called co-prime numbers because their common factor is 1. Okay, two numbers, also the definition we have defined here, that is the two numbers having no common factor other than 1 are called co-prime factors. Okay, so now if small a and small b are co-prime numbers, then they have no common factor other than 1, or we can say their highest common factor, that is the HCF of AB, will be equal to 1. Okay. Now example, if we are taking 12 and 17 or 21 and 22, 33 and 40, so these all are some examples of co-prime numbers. So okay, firstly we understand the co-prime numbers. Now our today's topic is revisiting irrational numbers. Okay, so the revisiting irrational number means that you already studied about the irrational number in class 9th, but which type of spatial theorem, okay, based on the irrational number, okay, and which is also related with the co-prime numbers. Let's see. Let P be a prime number. If P divides A square, then P divides A. Okay, so this theorem we will use to prove the irrationality of numbers. Again repeat, if P is a prime number, that is we have to given a prime number, and this prime number P divides A square, then P will also divides A. Okay, example, if 2 divides 8 square, 2 is a prime number and divides 8 square, then we can see that 2 also divides 8. In the similar way, if 7 divides 35 square, then we can say 7 divides 35 also, right? So now by this concept, now we prove the irrationality of numbers, prime numbers. Okay, so we just going to start exercise 1.3, and the first question is we have to prove that root 5 is irrational. Okay, so proving root 5 is irrational, let's see, we will prove it. The first thing, we prove all these type of question by the contradiction method. Okay, what is the meaning of contradiction? The meaning of contradiction, that is, firstly we take an assumption to start the proof. Okay, and in the last we conclude that our assumption is wrong. Okay, so this is the method called contradiction method. Okay, so we will prove it by the contradiction method. How? Let us assume that root 5 is a rational number. Okay, so firstly we assume that root 5 is a rational number. Now what is the rational number? Which are in the form of a by b or p by q, in which the denominator not equal to 0, and the condition is a and b are co-prime numbers. Okay, so also we just write down there exist co-prime numbers small a and small b are such that root 5 will be equal to a over b, or we can write down root 5b will be equal to small a. Now we can squaring both sides. So by squaring both sides, we will found that 5b square will be equal to a square. Now by 5b square is equal to a square, what we conclude? You can see that a square is multiple of 5. A square is multiple of 5. Now we can understand this by some example. Okay, so let's see. This is equation number 1. If 5 divides 15, okay, this is, we have taken an example to understand the concept. If 5 divides 15, so the meaning is 5 into some integer will be equal to 15, because 5 divide 15, that is 5 into 3, that will be equal to 15. So the meaning is that 5 divides a square, because here a square is multiple of 5. So when multiple of 5, the meaning is that 5 divides a square. And by the theorem, if any prime number divides a square, then meaning is that 5 divides a. Okay, and when 5 divides a, this is equation number 2, then a small a can be written in the form of multiple of 5, because 5 divides a. That's why a is multiple of 5. So in the multiple of 5, we have write down where c is any another integer, right? So now, substituting this value in equation number 1. So in equation number 1, we will put the value of a is equal to 5c. So we will found that 5b square will be equal to 5c whole square. Okay, and 5b square will be equal to 25c square. Dividing both sides by 5, then we will found that b square will be equal to 5c square. So we conclude that 5 divides b square, and by the theorem, if 5 divides b square, implies that 5 divides b. Okay, which is equation number 4, right? Now from 3 and 5, now by both the equation, that is, by both the result 5 divides a and 5 divides b, we conclude that 5 divides both a and b. When 5 divides both a and b, that is a and b both have the common factor 5. Okay, when a and b both have the common factor 5, which contradict our assumption that is a and b are co-prime, right? So this contradicts the fact that a and b are co-prime. So now we conclude that our assumption is wrong, that is root 5 is a rational number. So finally we say that root 5 is an irrational number. Okay, so this is the method to prove the irrationality of a prime number. Okay, now this is the method to prove the irrationality of square root of the prime numbers, right? Root 2, root 3, root 5. So in this method, we use the theorem, if p divides a squared, then p divides a. Also, you understand that is from where we have to start the question, that is we have to make an assumption that is root 5 is a rational number. In the last, we contradict our statement, right? So the next question we move. In the next question, now we have to prove that 3 plus 2 root 5 is an irrational number. Now again we will prove it by the contradiction method. We assume that this is a rational number, and rational number we know that it is in the form of a by b, where a and b are co-prime and small b is not equal to 0. So we will write down there exists co-prime small a and b. So 3 plus 2 root 5 will be equal to small a over b. So we can write down 2 root 5 is equal to a over b minus 3. Also 2 root 5 will be equal to a minus 3b over b. Now root 5 we can write down in the form of a minus 3b over 2b. Since a and b are integer, so a minus 3b over 2b is a rational number. Okay, so a minus 3b upon 2b is a rational number, and this also implies that when the RHS is a rational number, so we can also conclude that the LHS is also a rational number, that is root 5 is a rational number. But this contradict that root 5 is an irrational number. Okay, so our assumption is wrong, that is 3 plus 2 root 5 is a rational number. So finally we can say that 3 plus 2 root 5 is irrational. Okay, so I think you understand the concept clearly. That is how we are going to prove the irrationality of the given numbers, right? The next one, we also prove the irrationality of the 1 by root 2, that is 1 by root 2 is a irrational number. Again we just make some assumption, we again take the contradiction method. Again we will assume it equal to 1 by root 2 can be written as root 2 by root 2, that is root 2 by 2. Okay, so let us assume that root 2 by 2 is a rational. Okay, what is the rational? That it will be equal to a upon b, where a and b are co-prime numbers, right? And again, arrange this equation in such a way that root 2 is in LHS. Okay, so now we have to arrange like that root 2 will be on LHS and 2 will be cross multiplied. Okay, then it will be equal to 2a over b. Now 2a is an integer, b is also integer, which is not equal to 0. So what we conclude, that 2a over b is a rational number. So which implies that root 2 is also rational. So it implies that root 2 is also rational number. But this contradicts that root 2 is irrational. Okay, so finally what we will find, that is our assumption is wrong, that is this is rational number. So we can write down 1 by root 2 is an irrational number, right? So the next part of question number 3, 7 root 5 we have to prove. Okay, so 7 root 5 we have to prove irrational number. So again we will prove it by the contradiction method, and let us assume that this is rational. And what is the meaning of rational? That is, it should be in the form of a over b. Okay, so we will write down 7 root 5 in the form of a over b, where a and b are co-prime number, and root 5 will be equal to a over b or a over 7 into b, because we cross multiplied 7 here. Now we can see that a and b are integer, so we implies that integer upon integer, so this is a rational number. Okay, so which implies that root 5 is also a rational number, but this contradicts our fact that root 5 is irrational. So finally our assumption is wrong, that is 7 root 5 is a rational number. So finally 7 root 5 is a rational number. Okay, the next 6 plus root 2 we have to prove the irrational. Again we will prove it by the contradiction method. Okay, and then 6 plus 2 is rational, so it will be in the form of a over b, where a and b are co-prime. Okay, and now we shifted 6 on the right hand side, so it will be root 2 is equal to a over b minus 6, or a minus 6b over small b. Now a and b are integer, so it is implies that a minus 6b also integer, and finally this is integer upon integer, that is rational number. Okay, so we can say this is rational number, implies that root 2 is also rational number. Okay, but this contradicts our fact that 6 plus root 2 is rational. So finally we found that our assumption is wrong, and 6 plus root 2 is irrational number. Okay, so my dear students, in this lecture you found that how we prove the irrationality of the numbers by the help of the theorem p divides a squared, then p divides a, where p is a prime number. Okay, thanks to all of you, my dear students.